Hello, my name is Olga Maciaszek-Sharma, and I work for a Polish software house called Codarte. We mostly deal in backend, both Java and Groovy. And I will speak today about the Accurst Gradle Plugin. First, I will do a short introduction. Then I would like to tell a bit about the background, what were the circumstances when Accurst was created, and what were the requirements that it is trying to respond to. And then I will explain how it works, and I will show the solution itself. So, first, a short definition. Accurst is a plugin which is a consumer-driven contracts verifier. It takes in very easy-to-write Groovy DSL scripts that I will show you shortly. Then it works out of the box with Gradle, and since for the last 2 weeks also with Maven. And it will automatically generate YMOX stubs. And then it will also automatically generate Spock or JUnit tests. And when it comes to the tech stack, as I've said, it was primarily a Gradle plugin. Now we also have a Maven plugin that uses the same core library. It was primarily made for working with Java, but of course it can be used to work with any Groovy application as well. And when it comes to the tests that are executed, we support standalone application, mock MVC, and JAX-RS. So, how did Accurst start? Everything started in a project where we were working, and there was a big monolith application. So, all the functionalities were within a single logical executable. And it was a legacy system. It was very huge. It was complex. It was significantly entangled, both when it comes to the business logic as well as when it comes to modules. So there was an idea in the company that I was working at the moment to split it into microservices, because this monolith system was very costly to work with. Because first, it was very possible to make a small change in one module and suddenly it affected other modules and introduced bugs. It was very big, so the learning curve for the new developers to start working with it was really high and steep. Then it was tested within a pipeline deployment, so the system was basically deployed to a test environment, then some collaborators, then there were many end-to-end tests run, and it had to be that way because it was too complex to feel secure and safe with less tests or a simpler deployment process. So the deployment times were very long and it was costly. And then the people that were taking the decisions when it comes to the project future took the decision to make microservices, so to split this big monolith into smaller services, each one of them responsible for one major functionality. But, and the idea was that these services would communicate with each other using REST. And we would work in small teams, each team responsible for one or more services. So this has posed a lot of new issues and challenges, and there were a lot of different tools made in that company to deal with them. But I'm only going now to speak about the issues that we had when it comes to creating and modifying REST contracts, and when it comes to testing a microservice-based system, because those were the requirements that put the base for the creation of Accurst. So, when it comes to creating and modifying REST contracts, before there was one big monolith server with limited amount of clients or adapters connecting to it. And now we were supposed to have many servers and clients, many services communicating with each other both ways. So everybody would have to be defining and modifying REST contracts much more often. It would be changing dynamically. Also, the teams would work quite independently, and at the same time we could have a few different services communicating with the REST API of one other service. So if anything was changed in that API, we wanted all the teams to know about this quickly. And also there was this issue that different teams could request different changes in the API of any given service at the same time. And they could clash, then they would have to be a lot of talking, and it would take time. So when it comes to this part, creating and defining and modifying REST contracts, the idea that people have come up with was to have consumer-driven contracts, so that we would like the client services of any other service to modify or to suggest what the API should look like. So to propose new changes and to propose the endpoints and all the other parameters of the REST communication. And then what we wanted to have was for all the consumers and all the service teams to be notified and to know when anything has changed. And that was supposed to be automated in any way. And then another issue was changing from this monolith to microservices was testing the microservice-based system. We didn't have this kind of experience. So at that time, I was part of the QA team, and we had monolith end-to-end tests that were running against a fully deployed system with all the collaborators running and communicating, and they were very comprehensive. They verified what happened at the borders and that the communication was fine. So they considerably improved the safety. At the same time, there were probably too many of them, they were taking too long time, and the same code would be called again and again and executed again and again because they required similar setup. And now while changing to a new approach with microservices, we wouldn't be able to keep it this way. So we had to think of other possibilities. And there were different ideas that appeared. So one idea was one pipeline to rule them all. So to have all the services deployed to the test environment at one pipeline, everything tested with end-to-end tests, and then the deployment done to production always of all the services in the pipeline. But this would go against the very idea, because what we wanted to do is to have the microservices independent of each other. And then we would only have the independent development, but we wouldn't have independent deployment or testing. So that was not what anybody wanted. So another idea was to maintain more of such pipelines. So again, in one pipeline, all the microservices deployed, end-to-end test services communicating with each other, but only one service would be deployed through that pipeline. So we would have everything for the tests, but we would only deploy one service with this pipeline. So if something doesn't work with any other service, but we know that we have a version in production which works in a stable way with new version of the microservice that we want to deploy, we can go with that. But that would be extremely costly. When it comes to running it, organizing it, that would take a lot of resources, and nobody wanted to go this way either. So another idea that has appeared was to have stubs. That's a known solution. Everybody knows stubs, and they're widely used, but we had no experience when using them instead of the end-to-end system tests. So the concern that people had was that stubs would get corroded. Anything could have changed in the server, and the team that was using the stubs could not even know about this, and possibly they could use an outdated version of the stubs, everything would behave fine in the test, and then there would be a production fail. So the requirements when it comes to testing were that we wanted to have stubs, but at the same time, we wanted to do something to be sure that these stubs mirror the real behavior of the server, so that for any given request, the stub that we would get would be same or appropriate in keeping with what the server would do. So these were all the requirements that the Accurst team was working with. And then how Accurst works. Accurst is a plugin. So the idea that we had of this working was that the client service teams would submit these DSL scripts, groovy DSL scripts, defining the REST contracts to the server team. And then the server team could merge those scripts, and the WireMock stubs would be automatically generated based on those scripts. However, there would be also tests. So new stubs could only be published when all the tests have passed. And then the client would download those stubs and run their tests against those stubs. So this is a diagram of this, and I would like to go through this step by step and also show some code examples. So first, we were thinking that the client should submit DSL scripts as a pull request to the server code. And this is what an Accurst script looks like. It is, as you can see, very simple. It defines the standard parts of the HTTP communication. So we will have the request part and then the response part. We will have the method, the URL, the body. It can be given as a string or as a map. Then we would have headers. And in the response, we would, of course, have status. Yeah, and in the request, you do not need to have the body. You can, but you do not have to put this. And we would have the body and the headers again. So the server team would merge this pull request or start working with it. And then when they would run on their project Gradle clean build, stubs would be automatically generated. So these stubs are standard WireMock stubs because Accurst uses WireMock under the hood. And I don't know if many of you have experience working with WireMock. Has anybody used that? Okay, not many. So WireMock will launch an actual server, HTTP server, and will mount the stubs. And then any application can make calls against this WireMock instance, and for appropriate request, will get appropriate response as defined in the stubs. And this is a standard JSON format for the WireMock stubs. And this is the stub that was automatically generated from the input script. So when it comes to the request part, we can see that it's nearly same. It's just the URL being passed. Then the method. The body is changed to body patterns, and we check if it matches JSON paths. And for every headers, we check if the header content is equal to what we have defined in the script. Then in the response part, it's also similar. We'll change the status from our script into the stub. Then we'll change the body into body validation into the body part of WireMock JSON, and then the headers. Okay, so what happens is we have the stubs. The stubs can possibly be published. But with these stubs, what will get generated automatically by Accurst plugin when you run Gradle clean build are stub tests. And this is what the stub test for the script I've shown you before looks like. So this test basically checks if the server or our application really behaves as we have assumed in the script and as we have made in the stub. If it doesn't, then the server team has to implement the changes first, or has to refuse the pull request and not merge it. Because if they want to merge it, they have to make those tests pass. And the tests are automatically generated. They will be always run. So unless you, of course, do strange tweaks with Gradle, but that's not the point. So in this test, you'll see some methods used from REST Assured, which is a very nice library for verifying REST interactions, and from JSON asset, which is a library that makes nicer, simpler JSON assertions. So, coming back to our script, the body part and the headers part is changed into the rest assured request. Then we will use the method and the URL to make the actual call. And then we'll have to verify every part if it's fine. So we'll check the status, we'll check all the headers, and then the body will be passed. And for every element of the body that we have specified, there will be assertions made to check if we really get the same reply as we expect. So the only thing the users have to do to use this automatically generated test is to provide a base test class, because the container or the entire application has to be run, so these tests can be run against it. And there are, as I've said, various options. We have mock MVC, so we can use REST assured mock MVC, and this is as simple as this. We can just pass we can instantiate our controller in the standalone setup, and then REST assured mock MVC will make it work for us. And just with this line, the test that I've shown you will work. Or if we want to run it against a fully standing application, for example, when working with Spring, we have used web integration test, and we have passed some configuration, and then it raised the entire application. And we also have support for JAX-RS. Now, another thing which I think is very important, and that was one of the first things, because when Accurst was given to us to test and we started implementing changes in projects using Accurst and checking it, we've seen that one thing was wrong. We couldn't make tests because we didn't always want the stubs to only have the right response to a request which is very definite. Let's say we wanted to make a request with a client ID number, but we didn't want to always pass the same number. We wanted to have a number that would just match a certain pattern. So we asked the team that was working then on Accurst to implement it, and the regular expression support was added. So this is what it looks like in the script. As you can see, for this stub, we'll ask for a regex to be used, while in the case of the test, of course, we cannot test against a regex. If we are making a call, we need to pass a real value. So when it comes to stub, when we have passed the regex, instead of normal assertion, we will have a check for matching pattern, as you can see. And when it comes to test, we will have the right value passed. Now, another feature in the script is executing custom methods on the server. So sometimes the assertion that we want to make when it comes to checking if the response we have received is correct or not has a complex logic. It's just not one string that we check for equal or for matches. So in this case, we can define a method name, like is correct rejection reason here, and then in our base test class, we implement this method, which will verify if the value is correct. Of course, that's a simple thing, but you can have any logic in this method. And then, when the test will be automatically generated, we will get this call in the test to verify that element. When it comes to other available functionalities, we do support query parameters, also optional fields, and nested elements. That's particularly important when we are working with complex JSONs in the body. Sometimes they are quite complex, and Accurst will support it out of the box. So then what happens? These stubs are generated, the tests are passing, we can publish them. We can publish them to any repository, such as Maven repository. And this has to be done by the users alone. But that's very simple. At least in Gradle, you just use a jar task, and then you can use Maven publish plugin, for example, and these stubs will be published. The only important thing to remember here is that we want to couple the publication of the artifact and the publication of the stubs. So if we are having a Maven publication, we want to have one artifact being the real artifact of our application and the other one stubs. We don't want them to go apart. Every time we publish new artifact, we want a new version of stubs to be published. So then only we know that everything is matching. And now the client can download these stubs and use them. And until the beginning of this month, that was also up to the client to do. So for example, to write something in the Gradle script to get files from the right place and then use a wire mock rule to run them. But now, we have also added a stub runner tool to the Accurst project. And what stub runner does is it automatically downloads stubs from a repository, and then it launches WireMock under the hood with appropriate amount of server instances and mounts those stubs. So this had to be done before by the users using WireMock rules and using some Gradle scripting. Now it's also provided. And to use it on the client side, this is very easy. We just need to add to the dependencies and test compile any one of those or more, depending on our project. So we can use it with the JUnit rule that is provided. And this is how you would use it. It's very simple. Just on the test, you have to make the rule. You need to pass the root of your repository, whatever address you have. Then you need to write in download stub, you need to pass either the artifact ID the group ID or the IV notation. And you can also add some additional options. So here I have minimum port and maximum port. In the documentation, you can see what options are supported there. So what will happen if you put this rule is that the stubs for the artifact with the ID or the IV notation specified will be automatically downloaded from that repository. WireMock instances will be launched, and any test can be now run against those stubs. Also, the GNUnit Accurst rule implements the stub finder interface. This is what it looks like, and it allows us to get the actual URL on which we can get the particular stub, and also get all running URLs, all running stubs. Apart from this, Stub Runner has out-of-the-box support for Spring and Spring Cloud. So there is Stub Runner configuration, and if you import it, same as with the Accurst rule, you just need to pass the repo root and the IDs of whatever stubs you want to use, and then the stubs will be running for you just with this configuration. And also they will be run using a class which implements Stub Finder. So you will have access to all this data that we have seen before, and we can just auto-aware Stub Finder, and the right instance will be found, and we can get all the stubs running as well as the URLs. And also, when it comes to Spring Cloud, we have a Stub Runner Discovery client, which implements the Spring Discovery client, and which will allow you to get the stubs as the clients. So if you work with Spring or Spring Cloud, this is very useful because it will just treat those stubs as if you had real clients working with you. Okay, when it comes to possible issues that we've had is that Accurst has been made mostly with microservices in mind. And it works pretty well with them. However, while implementing this in more complex systems, sometimes it appears that if we need to stub, we need to also do a lot of mocking and stubbing, for example, of Spring configuration or other elements, and the Gradle setup becomes complex. So it is possible to use it in big systems, but it's really designed mostly for microservices and smaller applications. Because, yeah, in the test-based class, you would have to have a lot of setup. Okay, and also Accurst is a young solution. I think it's now 1 year old, so it means there are still different bugs appearing. But on the other hand, the team is working very actively on it, So if you use it and you have any issue, probably if you register it, it will be very fast fixed. And now I will check how much time we have. Okay, I would like to show it in practice, the way it works. Okay, so this is a, no, I will make it bigger maybe. Yeah. This is a sample project. Please do not put too much attention to the code. This has been only prepared for using as an example in Accurst workshops and presentations. And here in this project, we have one controller. And this controller has a very simple logic. It will either return a fraud check result, okay, or if the amount is too high, it will return the amount is too high, and it will return the fraud result. And this logic is now commented out, because I want to show you what happens if the application doesn't work as the Groovy DSL script expects it to. Okay, so we have the build part. For now, I will just remove it. So we want to see it work fresh, and these are our scripts. So this is the first script. As you can see, it's fairly similar to what we have seen in the presentation, and it will pass an amount which is too high, and it will expect to get a response, and in the body, the fraud check status should be fraud, and the rejection reason amount too high. And then we have another script which is appropriate for a correct situation. So amount is not too high, and we want to get an OK status. So now what will happen if we run it? 1 second. If we run clean build, we expect the test actually to fail because some part of the logic is not there, so it doesn't really behave the way. I'm sorry, that's not the project. Sorry, wrong window. Okay, and some part doesn't really behave as we think it will. This one should fail. And it has, and if we check it, so here's our test result. We don't have the JSON that we expected, and when we see the test, now we get the build, and in the build we will have the test here because this is the place we have put in the configuration that we want to have it in. Let me show you the tests. So this one actually has failed because it has not found the right body. Okay, so now we also have the stubs. Okay, it looks strange now. Okay. So these are our stubs, but we cannot publish them yet because our tests are failing. Okay, so now if we modify this and we remove this comment to get the right logic, and we run it again, what we are expecting is that the test should pass. It's not this project. Okay, it's this one. Okay, so it passes. And now we can also publish these stubs wherever we want to have them. And let me show you just the setup, how they're published. So we are simply using the standard Maven Publish plugin from Gradle. The newer publishing plugin is better because it allows you to put more artifacts. And as I've told you, the good thing would be to have both the stubs and the artifact together. And here we just make the stub jar. Okay. So we have this setup, and now using this setup, we want to publish it to our local Maven. Of course, we can publish it wherever. Okay, and now, using the group ID and artifact ID, in our Maven repository, we should have these stubs in the right place. So we check it, and they're here. Normally, of course, it would be some online repository. And now we have another service. So this is our loan application service. And in this service, we have, we are trying to connect to the other service that I've just shown you. And we are expecting to get the right fraud check status. So here the request is being made using REST template. And we want to get the right response, and we want to test it. But we want to test it without having the other service running. So to do that, we will have this Accurst rule. And as you can see, here we have an IV notation corresponding to the artifact ID and group that we had here. And we have our test, and in this test, we assume that instead of connecting to our regular URL, we will connect to the URL where the stubs are mounted by this Accurst rule. And there will be a port which will be chosen randomly from a range. So what we are doing is we are getting the right URL with the right port, and then our client will connect to this URL instead of the real instance that is not running. So now we expect to run it, and we expect the test to pass. So I will try running it. And as you've seen, the other service is not running. OK, so this has worked. And when it comes to the demo, I can also show you, in this script, that here we are exactly using this regex. So we are expecting only a value matching this regex pattern and not exact value, while the test takes an exact value from us. So I think this is the short demo. And if you have any questions, then I would like to be taking them. Anybody? Okay. So maybe I'll ask you some questions. Have you ever had such kind of situations where you wanted to be testing the REST contracts or working? Yeah? Yeah, and what solutions have you used, and do you think that this solution would be helpful?
Yeah, I usually wrote a mock service that was integrated to the client to create a snapshot.
Mm-hmm. And do you think this should be useful, or you think it should have some other changes? Yeah, because I'm also here to show it, but I'm also here to get feedback, because we are quite actively working on it, and we want to make it useful to people. We have some users that are using it in their systems, but we still want more people to use it, and we want to make it in a way that it will be useful. So if, let me show you also 1 second. So in this, I want to show you these links because here you will have the repositories with the implementation. So both this client service and the service that had the script and with the branches provided. So you can see the code more in detail. And if you have any questions or you want to ask more things about that, then I will be here during the conference today and also tomorrow. And I'm happy to talk about it. Also, if you think there's anything that should be improved or you think is lacking and you would need this, then let me know. What else? Accurst is completely open source. So if anybody wants to contribute or place issues, then you are welcome to do so. I think we have still some 5 minutes. So if there are any... Yep.
Maybe one question. We have REST microservices, but we also have asynchronous microservices that are executed via message passing. So have you thought about a solution to this kind of problems for message-based?
We haven't tried doing it yet because we haven't. Because we had different connection, but actually there was an idea to make it. I think it will be a bit different, definitely, from this, but as we mostly use the REST communication, so that was what we needed. However, if there is interest, then definitely we can work on it, because I think it's also going to be useful. So we've not worked on it, but there has been some ideas, and it's developing really fast. Like StubRunner was added just 1 week ago. The Maven plugin was made 2 weeks ago. So if there is need and you make as an issue that this would be useful and we would use it, then we can just sit and implement it, or you can also submit a pull request and we'll be happy to take it in. The important thing for us is only this, that always there has to be this assurance that the server actually behaves as we think it does, and that the input should be one. So the input for the test for the server and for the stubs or any other product should be generated from one source. Any other questions? Okay, so thank you very much. Sorry, I can't see because it's dark, yeah? Okay. Yes, I guess it can be used, but the main point of this DSL was to make an easy way to describe the REST communication. And I'm not sure how you would like to use it, like what kind of case or test scenario you would like.
You want to specify in your test the specific data.
Mm-hmm. That override the DSL? No, because the whole point for us is to have this sure knowledge that our stub really reflects our server. So that's why it's automatically generated, because that was our problem, that we thought we can make stubs, anybody can write stubs, but how do we know that somebody has not changed some endpoint in the server and that now instead of returning OK, it will return something else for the same request? So that's why it's so much tightly coupled together. Okay, any other question? Okay, thank you very much.